Hello, welcome to the lecture. So in this lecture, we will continue our concrete design concepts. So in the previous two lectures, we have introduced with some of the concepts that are related to the reinforced concrete design. And in this lecture also, we will see some more concepts which are being used while designing the section, we should understand those concepts also. So these are the concepts that I will be discussing today. So in this lecture, we will see the modes of failure of reinforced concrete beam section, and then we will see the expression of moment of resistance for different sections. So when we talk about the modes of failure of RC beam or reinforced beam section, well, the modes of failure are basically of three types, and those are the beam can have failure uh, in terms of balanced sections, and in terms of under reinforced sections, and in terms of over reinforced sections. So in the balanced section, as the name suggests, so in this case, what happens is reinforced concrete beam section in which the tension steel reaches yield strain simultaneously as the concrete reaches the failure strain in bending are called the balanced sections. It means that the failure of concrete and failure of steel takes place at the same time. So that is the section called balanced section. In case of under reinforced section, as the name suggests, that in this reinforcement will be lower, as lower than the required. So in this case, reinforced, the steel will reach failure strain first, and concrete will reach, without, in the concrete, the failure may not takes place, but steel will be considered as failed failed because the yield strain will takes place before the concrete reaches failure strain. As in this case, you can see reinforced concrete beam sections in which steel reaches yield strain at loads lower than the load at which concrete reaches failure strain. So basically in this case, what happens is we consider that we are providing steel lower than the required, and because of that, steel will fail first, while the concrete still have some capacity to take the load. While in the third case of failure, which is called the over reinforced section, so in this case, what we do is we provide steel uh, more than required. So in that case, steel will not fail, but concrete will fail first. It means concrete will reach its failure strain first, while steel still has capacity to take the load. So that is the case of over reinforced section. So in the balanced section, steel and concrete will reach at the failure strain at the same time, while in case of under reinforced section, steel will fail first, and concrete still have some capacity to take the load, while in case of over reinforced section, steel will have the capacity while concrete will fail first in case of over reinforced section. So we will see these sections in more detail in the next slide. So now first we will consider the balanced section. So as I said that failure of steel and concrete will take place simultaneously. So what does it means? It means that the strain, the stress in the steel, the actual stress in the steel will be equal to the permissible stress. Similarly, the stress in concrete, actual stress in concrete will be equals to the permissible stress. So that is the maximum stress that a concrete can be, we can apply. So if stress limit reaches this value, it means we will consider that concrete is failed. Similarly, in case of steel, if the stress value reaches this sigma st value, then we will say that we will consider that steel is failed. So in this case, we can say that FST will be equals to sigma st and FCBC will be equals to sigma CBC. So now with this, we can have some relation. So in the previous lecture, I have explained this n value. This n value is called the neutral axis factor. So this we have seen how we get this value. So n is equals to 1 by 1 plus sigma st by m sigma cbc. Or we can rearrange this as m into sigma cbc upon m into sigma cbc plus sigma st. So we can rearrange this also, but for the time being we will use this part only. And here it says under the condition of balanced section, we call n as n naught. So whenever we are using n naught, it means we are talking about we are talking in terms of balanced section. So in case of balanced section, n will be equivalent to n naught and its value will be equivalent to 1 by 1 plus sigma st upon m into sigma cbc. If we further put the value of m as per IS code, so as per IS code, m is equals to 280 by 3 sigma cbc. So if we replace this value in place of m, then it may further modified as this value. So in this case, we can write this as 1 upon 1 plus 3 sigma st upon 280. So with this relation, we can say that the balanced section is, the neutral axis factor is mainly dependent on the permissible stress in steel in case of balanced section. So here I have also written that neutral axis coefficient depends only upon the stress in tension steel, because with this relation it is clear. So that is one thing that we have considered in case of balanced section. Similarly, if we try to find out other factors like the J naught, like the P naught, I mean, I'm saying this naught because we are talking about the balanced section. In the uh, in the balanced section, the amount of steel that we provide, it is expressed as AST bell, which is tensile steel in the balanced section. And the P factor is called reinforcement factor. So in case of balanced section, P will be equivalent to P naught, and P naught is calculated as AST balance by BD, while you may remember that P value was actually equivalent to AST upon BD. So in case of P naught, AST is replaced by AST balance. And further, in the previous lecture, I have shown you how we can change this value to this value. So you can refer to that lecture to see how this value is changed to this value. So here I am writing this directly. So this value is equivalent to this value also. So we are using this different expression so that in the problems we can use any expression to find the required value. Similarly, other factors like in case of J was called lever arm factor. So in normally it is known as J, but in case of balanced section, we add this subscript with the naught. So in this case, J naught will be calculated as 1 minus n naught by 3. So again, this relation we have seen how it is being evolved. So all these relationship I have already explained in the previous lecture. So if you are not clear with this, please refer to that lecture. So here I am writing these value directly. So J naught is also equivalent to 1 minus n naught by 3. So we will continue this lecture in the next part. Thank you.